If you know the sigma value, then you can conduct the Z test. If you don't know the population standard deviation, then the only other option we are left with is T test. And the T test itself, we have different types are available. The one is the single sample T test and two independent sample T test. And within two independent sample T test itself, we have two variants. One is equivariance and unequal variance between the population. And the other one is pad T test, okay? So now, since few of you asked, right, you sent a message about the t-test. Yes, there are some calculation problem. Will give you a recap once again. When you do not know the population standard deviation, in the case of single sample, right? So let's say you want to compare the sample mean with the population mean. In that kind of case, right, you do not know the population standard deviation. The only test which you can conduct is the t-test, okay? So in this case, we compare the mean of a single sample differs significantly from the population mean, hypothesized population mean, or the unknown, right? So sorry, from the hypothesized population mean, okay? When your population standard deviation is not known, then we can use the one sample t-test. So so to conduct this test, these are the assumptions that needs to be met. We discussed already, right? So in the case of t-test, the data must be independent in your sample, okay? And it is a continuous variable. And for example, the mileage, we discussed about the car mileage, that is a continuous variable. And normally the population should be normally distributed. And it uses t distribution instead of z distribution, because the t-test, there is something called t distribution. Okay. What is the difference between t distribution and z distribution? At this moment, you just think, right? The tails are, the tails are little bit fatter than the normal z distribution. Okay, that is the difference between these two. In the case of t distribution, right? So we consider something called degrees of freedom. Okay, the minimum sample size should be 30. Okay, so in that kind of situation, also we conduct the t-test. These are the prerequisites that needs to be met. Data must be independent, continuous, normally distributed, and so on. Okay. And what is the difference between Z and t-test? We have already discussed about. The difference is standard deviation of the population we do not know, then z-test. If you know that, then it is z-test. If you do not know the population standard deviation, t-test, we need to conduct. The test statistic formula differs for these two, and z-test uses standard normal distribution, whereas t-test uses t distribution. In the interview, they'll ask you. You need to be very clear on this one, okay? Next one is the case study single sample hypothesis test. Since a few of you asked me to repeat this, I'm going to repeat it. And yeah, so yeah, there was some the calculation problem. I agree that I fixed it. Don't worry. Okay, we'll continue. Let's say you work for beverage company that produces energy drinks. So in this case, the company claims that the energy, the can of energy drink is supposed to contain 500 ml of liquid. Okay. However, some customers claim that the company is not providing the promised quantity or the advertised quantity. So you want to test the claim, and to test this, you randomly sampled 50 cans, and then you found the mean for your sampled cans are 498 ml, and then your sample standard deviation 8 ml. In this case, we do not know the population standard deviation. So here the question is, you want to conclude, or is there enough evidence at the 5% significance level to support the customer's claim that the company is not providing the advertised or promised quantity of liquid? Okay. Yes, it is not promised. See, they printed on top of the can. That means, right, they should stick to that. Okay, the formula for t-test is almost similar to your z-test. Only differences in the denominator. Instead of having population standard deviation, we need to use the sample standard deviation, because in the case of t-test, we do not know population standard deviation. We just wrote down all the data which we have it here, right? So as per the case study, we have noted down what is the population hypothesized mean, and what the sample mean, sample standard deviation, what is the sample size, and what is the alpha value, we noted down here. So once, since we have already noted down here, we just need to plug in these values here. That's all. Okay. Once you plug in that, you're all set. You'll get some value that is called your test statistic value. We need to, so, okay, what is the purpose of computing the test statistic value? See, there is a formula, is there test statistic? Okay. So, but we need to use it, right? So it'll give you some value, right? So we need to compare this value with something else called the critical value. Okay. We need to compare this value with the critical value. If this value is less than the critical value, then it will fall in the rejection region area. If this value, if the t value is above the critical value, also it will fall in the rejection region area. If it is not less than the critical value or greater than the critical value, it is going to fall in the non-rejection region area. This is what your critical value, right? So critical value. So this is what your non-rejection area. If the t values, less than this one will fall here, and the t values greater than this one, it will fall here. Or if it is not less than or greater than, then it will fall somewhere here, right? This is what your non-rejection region area. Yes, Leela, I'll come back to that. The alpha is, you got confused with alpha, right? See here, alpha, why we are using is, so we are defining the null hypothesis. What is the probability that we are going to reject the null hypothesis? Okay, the true null hypothesis, something like that. Okay, what is the probability that we are rejecting the true? See, the test statistics, it's a formula. It gives you some value. If you simply compare, the t-test statistic value is less than critical value, and if you reject it, for example, a person is actually innocent, that is the true null hypothesis. But if you reject it, then what will happen? So here, for that, we have something called alpha value. We use it. This is the conventional value. What is the probability that true null hypothesis can get rejected? There is a 5% chances that true null hypothesis can get rejected. There is a 95% chance that it will not get rejected. That is what we are going to say. Okay. So as per the steps, first create the, define the, formulate the null hypothesis and alternate hypothesis. And what you want to test, that is what you are going to have it in the alternative. We want to conduct the two-tailed test, mu not equal to 500, which means it is neither greater than 500 nor less than 500. Sorry, it is not equal to 500, which means, it is less than 500. Sorry, okay, it is greater than 500. So that is what we want to test. This will be a two-tailed test, because not equal to, whenever you notice a not equal, that means a two-tailed test. The quantity could be higher or lower, okay? And also the sigma is not known, hence we will have to use the t distribution. And alpha value, it is the probability of making type 1 error. So we'll see what is type 1 error that the user is willing to accept. So there is a 5% chance that even the true null hypothesis can also get rejected. So then it is fine. There will be a risk, right? It is kind of a risk. How much risk are we going to take? That's all. Next one is the decision rule. If the t value is less than, this is your critical value. How did we get this one? You don't worry about that. For the two-tailed test, blindly you just think negative 1.96 and positive 1.96. Okay, reject the null hypothesis. If it is greater than this, sorry, if it is less than this, okay, here there is a mistake. The t value is less than this one, or if it is greater than this one, okay, then we need to reject the null hypothesis. So what is the t value here? This is what my t value. Yes, Leela, this is what the calculation problem. Now it is correct. Here I put to 49 mistakenly, but here it is a sample size, square root of n, not the degrees of freedom. But there is something specific to t-test. The t-test, we do not, when we do not know the population standard, we conduct the t-test. Apart from this, when it comes to t-test, you need to find the degrees of freedom, which means, what is degrees of freedom? Your sample size minus 1. That's all. That is what your degrees of freedom. Okay, now you understood. Okay, and in this case, we just simply, we have all the values. We just plug in the value. This is what the sample mean. This is the hypothesis population mean. This is the sample standard deviation, square root of the sample size. If you solve this, you get negative 1.198. So now you tell me negative 1.118 is less than negative 1.96? No, right? It is not less than that. Hence, we fail to reject the null hypothesis. Okay, we failed to reject the null. So in this case, right? So there is a minus 1 point. So, okay. Okay, this is, whatever I mentioned is not company is. Yeah, there is enough to support the customer that the company is not providing the advertised quantity. So we fail to reject the null hypothesis. Since this value, the t-statistic value is not less than negative 1.96, we fail to reject the null hypothesis. What is our null hypothesis? We assumed that the can will be, or whatever the statement made by the manufacturer was correct. The 500 ml is there in the can. That is, correct. That is what, we assumed that. But we did the sampling, everything, and finally, when with the statistic value, when we compared with the critical value, we could see that we failed to reject the null hypothesis. That means, we are going to accept the null hypothesis. We never say, we are going to accept the null hypothesis. For your understanding, I just told this one. But as per in statistics language, we have to say fail to reject the null hypothesis. Since minus 1.118 is greater than minus 1.96, which is your critical value. So these are the standard value. Just think that, okay, for a two-tail test, okay, minus 1 point. So we failed to reject the null hypothesis. That means there is no enough evidence to support the claim that companies' energy drink cans do not contain the advertised quantity. Sorry, this is wrong. Company is not providing. This is wrong here because of the calculation mistake. Okay, so in this case, we don't have enough evidence to support the claim that the company's energy cannot contain the advertised quantity. So we can say the other way around also. With 5% significance level, we fail to reject the null hypothesis, right? Or we can say the other way around also. We are 95% confident. We are 95% confident that the customers claim that the company is sorry, we cannot say, yeah, in this case, we fail to reject the null hypothesis, right? Yeah. So we are 95% that the, whatever the statement made by the customer is, the manufacturer is correct, right? That is what we can say that. So we don't have enough evidence to support the claim that the company's energy drink cans don't contain the advertised quantity, right? We don't have evidence to do that. If we reject the null hypothesis, for example, whatever the t statistic value you get it, if it is less than this critical value, then we have an evidence with 5% significant level. We can say that, we can, so we can state that the customer claim that the company is not providing the advanced quantity. But in this case, we fail to reject the null hypothesis. Very simple one. Don't break your head too much. Okay. The p-value, everything we'll see it later. I will just go to the Python. I will show you here the same test. You will be surprised. It will be very simple one. Look here, all the values I noted down here. The sample mean, everything very simple. And this is the formula, right? I simply put the formula here. Degrees of freedom also I put. Alpha value I put. And this is the function. Gives us the the critical value. We don't have to break our head in terms of looking up the table and all. Okay. And if you want the critical value, it gives you. If you want the p-value, you need to multiply this one. Okay. You need to pass the test statistic value to your CDF function and multiply this by 2. It will give you the p-value. It's all readily available. You don't have to worry. So only thing is just click on it and run it. And you can see that t-test statistic values, in this case, yeah, minus 1 point. So there will be some kind of variation, right? Manual calculation and this one. Let me see here. Sample size is 50 here. Okay, population mean is 500. Minus 1.18 should come here, but here it comes something like that. Okay, the sample mean is 48, population mean is 500, and the p-value also it gives us, and the degrees of freedom it gives us, critical t-value also it gives us. Critical t value also it gives us. Okay, and then critical value it gives us, and then the significance level, everything it gives us. Yeah, because the alpha value may mention 0.05, and p value also if we compare. I told you p is less than alpha. This is another way of checking it. What is our alpha value? P is less than alpha, reject null hypothesis. H sub 0, reject the null hypothesis. This is a universal truth. Okay, so here the p value is 0.83, but alpha value is 0.05. Since 0.83 is not less than this one, we fail to reject the null hypothesis. Even with p value, we can conclude that we fail to reject the null hypothesis. And also even with the critical value, yeah, here it shows the critical value is 2.09 and minus 1.6 here, right? So it shows 2.09 minus 1.76. In this case, the negative value, this one is not greater than 2.095. Okay, and in this case, the negative value is minus 2.095, and in this case, two-tailed test, right? So it is not minus 1.76. Is not less than this one. It is not greater than this one. Hence, we fail to reject the null hypothesis. Even with critical value, even with the p value method, we fail to reject the null hypothesis. But this is very simple. See, p value, we don't have to break our head. It gives us the p value automatically. Okay, so 0.83, and 0.83 is not less than 0.05. Hence, we fail to reject the null hypothesis. That's all. Okay, you don't have to worry too much in terms of looking up the table, because if you look at in the online, for the t distribution, you will not find more than 30, the degrees of freedom. So you will, in the case of p value, right, you will find you will find something like this table, degrees of freedom, and then 0.95. For example, if you are using alpha equal to 0.05, right, so p, right, so this is the one. And if you see here, for example, in this case, we have 39 degrees of freedom, right? 39 or 50, right? 49 freedoms of, yeah. So in this case, it's difficult to find out the value here. Better you can go for, you go with the statistical software instead of manually doing it. When it comes to finding out the p-value or the critical value, better you can rely on this statistical software. Don't worry, Leela and Sangeeta, I'll share the script. Don't worry, okay? Yeah, those of you do not have laptop, 1 second. I will just slowly scroll this up and down so that it will get recorded and you can watch it. Look here, first you need to import the packages. These are called the packages. Someone has developed these packages. Simply we are using their packages by importing it, okay? Next one is you need to assign a variable, okay? You need to assign the values to the variable. You can give some meaningful name, okay? And then this is the formula, okay? And then alpha equal to 0.05. And this is the one gives us the t value. And this is the one gives us the p value. And here just I'm simply printing that, okay? And then here we are comparing the t statistic value with the critical t value. And since look here, conclusion, fail to reject the null hypothesis. Else, right? Since this is not greater than this one, we fail to reject the null hypothesis. sorry, this is greater than this one, we reject the null hypothesis. It's slightly different. Okay, so even if somebody is asking in a very tricky way, you should be able to answer the question. That's the reason why I put it like this. There is no statistically significant difference between the sample mean and the advertised quantity. So the difference is maybe negligible. Okay, hence we cannot reject the null hypothesis. We are going to conclude that whatever the claim made by the manufacturer was correct only. Next one is the two independent sample t-test. So what is two independent sample t-test? As the name suggests, you need to draw sample from two different populations. Hence, these samples are completely independent. The simple example is, this is male population, this is female population. You want to compare the average salary drawn by male and female or same. Let's say you work for Infosys. Okay, you want to compare the average salary drawn by male and so Infosys, let's you are a data scientist with let's on an average 4-year experience person. You have taken the population of 4 years experienced data scientist, which includes male and female. But in this case, male population, you are drawing the sample, and female population, you are drawing another sample. Both the samples are independent. So we need to compare these two samples mean, x1 bar, x2 bar, are they same? Because we do not know the population average salary and for the both male and female. Hence, we are drawing this sample and we are going to conduct the t-test, two independent sample t-test, and we are going to conclude whether there is any statistically different or the means are statistically different or not. That is what we are going to conclude. That's all. So other example is, let's say this is a north region, this is a south region. In the case of retail, the average amount spent by the customers in north region, average amount spent by the customers in south region. North region is population is completely different, south region population is completely different. If you draw the sample, obviously these two samples are completely independent. Right, so we need to compare the means of these two samples. Okay, that's all. Okay, so here within this two independent, this is the whole idea of two independent sample t-test. It's pretty simple. Previously, we have taken only one population. In the case of manufacturer, the energy drink manufacturer, we have drawn the sample from the manufacturer, that specific manufacturer's related cans, right? Hence, only one population was there. But in this case, we are going to draw this sample from two different population. And then we are going to compare, or the means of these two samples are statistically different. If it is statistically different, then we are going to conclude that in the previous example, males, the average salary drawn by the male is different from the average salary drawn by the female. There is a gender bias here. In USA, it is a crime. It's a serious issue. Gender bias should not be there. Okay. So like I said, in the case of two independent sample t-test, we compare the means of two independent or unpaired groups. The groups are considered independent if the observation one group are not related to observation other group. What do you mean by independent? Right, so there should not be any dependency here, right? If the observation one group are not related, observations are nothing but your sample. Okay, the samples in one group are not related to the samples in the other group. The reason why I use different terms, I already told you, because end of the day, every day your status call with your American customer at offshore. Okay, so in that case, they will not see your face. Everything will happen over voice over IP, and they will use different terms. Okay, you need to still, you should not get confused, right? That's the reason why I put this observation, nothing but the samples. Within this two independent sample t-test, there are two types are there. One is the equal variance t-test and unequal variance t-test. What do you mean by variance? See, in this case, what is equal variance? Just remember that the image. Okay, so there are two different populations. We have drawn this sample, but these two populations variance are similar. Okay, it will not be similar it may sound weird, but still, right? We assume that there will be a there will be somewhat closer. Okay, you just think that way. Okay, the variance is somewhat close, though it is not exactly similar. Somewhat the variance is similar. For example, male salary variance and female variance, the variance is somewhat close. Okay, in that kind of situation, you can go for equal variance t-test. Within the two independent sample t-test, there are two types. One is the equal variance. Both the population variance are equal or are almost equal. Okay, close to same, something like that. So it is also called as a pooled variance t-test. But there are cases, it will not be same. The variance may not be same. So in that kind of situation, we call that as an unequal variance test. It is also called as a Welch's t-test. Welch's t-test. Okay, in this case, we will take a look at what is the difference between these two. So if the variances are not same, we call that as a Welch's t-test. So does that mean the formulas are going to change? Yes, obviously the formulas are going to change. So in the case of equal variance t-test, x1 bar minus x2 bar divided by the pooled standard deviation into square root of 1 divided by n1 plus 1 divided by n2. Here the x1 bar and x2 bar sample means of two different populations respectively, or two different groups respectively. Here the SP is nothing but this formula. Okay, the SP is equivalent to square root of n1 minus 1, which means sample 1 minus 1, and then sample 1's standard deviation squared plus sample 2 minus 1, degrees of freedom. This is your degree. If you subtract 1 from your sample, that is called your degrees of freedom. This is sample 1's degrees of freedom, sample 2's degrees of freedom. So sample 1 degrees of freedom into S12, the standard deviation of the sample 1 squared, that is what we can say in the denominator, n1 plus sample 1, how many samples were there in the first sample, and second sample, how many number of observations are there, minus 2. So here S1 squared, or the sample variance of. So if you square the standard deviation, what is that? That is your variances, sample variance of group 1 and group 2. So this SP you need to find out, and then multiply that value with this one in the denominator, and then you subtract this one in the numerator, and then you solve this. Whatever the value you get it, that is what your t-test statistic. Again, the same rule. If the t-statistic values less than the critical value or greater than the critical value, it will fall in the rejection region area. If it is not, then it is not going to fall in the rejection region area. It is going to fall in the non-rejection region area. That rule is same. So we have different formula for unequal variance test. In this case, the denominator, if you see here, the variance of your first sample divided by n1 plus the variance of your second sample divided by the n2. Here the formula is slightly simple than this one, right? So, okay. These are the two formulas. And when it comes to assumptions, so what are the assumptions? It makes both the test. So both of them make the same assumptions. So the observations within each group should be independent. The normality, see, this is almost same for everything, right? Even in the case of Z distribution, normality, the normal distribution, we are assuming that the population is normal, and the sample, whatever you draw, it is independent. And then, but this is specific to your equal variances in the two independent sample. The variance are assumed to be equal in the population. Welch teaches variance are assumed to be unequal in the populations. Okay, these are the two assumptions we make it. We'll go ahead and take a look at an interesting two independent sample t-test, which is nothing but the equal variance t-test case study. Okay. Let's say a company, right, is considering the company is considering a new production process to improve the efficiency of the manufacturing line. They want to determine whether new process statistically significant, better than the current process in terms of production output. To make this decision, they decided to conduct a two-sample independent t-test, assuming equal variances. So what they are doing is they want to improve the efficiency of manufacturing line. For example, they want to improve the productivity. Okay, so what they did, they used the two different, this population data. So before introducing the new process, after introducing new process. Okay, or for example, training. Let's say in the production unit, let's say you are running a manufacturing unit and you bought the machines, and somehow you train them, your people, and you ask them to do it. Okay, but you do not give the proper training, and you ask the leads, the project leader or manager, someone, right, to train them on the job and let them do the work. In that case, what happened? You have noted down the production output, how many units produced by each machine, something like that. You noted down, and then what you are doing? Hey, let's give proper training. We'll send them for 3 days crash course. After attending the training, what is the output? You are going to note it down. So you want to compare before and after, right? So are there any differences here? So assuming equal variances, conducted two sample independent data, determine whether there is a statistically significant difference in the mean production output between the two processes at 95% confidence interval. Okay. In this case, obviously, right, we have the data here, the sample data itself given. Population standard deviation we do not know, hence is a t-test. And here they mention that equal variances. Okay, and here our job is to find out the sample mean for sample A. Other sample also we need to find out the mean and standard deviation. Very simple. And the formula we know, this is the pooled standard deviation. Plug in the values here. We know the sample standard deviation and everything here, and we just simply plug in the value. 6.45 is the standard deviation for the sample variance of your sample 1, and 2.37 is your second sample's variance. Add this 12 divided by 2, you get 4.77. And you plug in all the values into this is the final formula. Okay, and then SP value we already know. This is what your SP value, 4.77 multiply. Finally, you end up getting the test statistic values negative 10.50. Negative 10.50. So now you need to compare the t-test statistic value or critical value. So let's not break our head. We just go to the statistical software. Let's say you are a smart guy, right? So what you do is you don't want to look up and all, and it's a two independent the equal variance. Yeah, the same example I've used it here. Look here, everything I made your job simple. And in this case, there is a function called t-test independent. Okay, two sample t-test independent. There is a package that is there is a function or method that is available for stats package. You don't worry about anything here. Let us simply click on the run, and let's see here. What is sample mean? Sample A mean, sample B mean, and are these two are same? By looking at the itself, we can say it is not same. And but here the t statistic value is given, and minus 13.65, and there is a difference here, right? Minus 10.50. Okay, and the p value is 4.52. Okay, and the critical value also given here. Okay, let's say the critical value in this case, what is the in this case the critical value is plus or minus 2.001. Correct, 2.001 here. So here, what is the t-test statistic value? Minus 13.65. What is my the critical value? 2.09. Since it's a two-tail test, let's say if it is a two-tail test, right? Your t-statistic value should be less than negative 2.001. You just think that way. Or if the t-statistic value is plus 2.001. So in that case, you are going to reject the null hypothesis. This is the rule, right? If the test statistic value is less than this value, you are going to reject. So what is our value? Is this less than this one? Is this less than this one? Yes, right? Minus 13.65 is obviously less than this one. Hence, we reject the null hypothesis. And we will compare, we will use the p-value method also. P-values, does the p-value is less than alpha? 0.05. Can someone tell me? Let me see how many of you can answer it correctly. Does this p-value is less than alpha? Alpha is 0.05. What is p-value? What is the p-value here? It is there, right? 4.52. Can I say 4.52 is not less than 0.05. You need to look here something, E minus 20, which means when you see anything followed by the value, right? Anything for, like E minus 20 or E minus something followed by value, that means the very, very less value, which means you need to prefix 19 or 20 zeros before this one, which means here 0 point, sorry, here 0.00019 zeros you need to put before this. 0.00000 something like that, 452. So this one is nothing but 0, right? Your p-value is 0 here. 0 is less than alpha 0.05. Hence, we are going to reject the null hypothesis. Even with p-value, you conclude that we reject the null hypothesis. There is a statistically significant difference in the mean production output between the two processes, which means before training, after training, right? There is a difference here. Since the critical value t test static values is less than the critical value, right? We reject the null hypothesis. For a 95% confidence interval, what is the sample here? The sample sizes in this case. Yeah, here the 1 second, here it will be there, right? The sample mean degrees of freedom is 60. In this case, 60. So in this case, what you need to do is you need to subtract 1 from sample 1 and subtract 1 from sample 2. So you get 58. The degrees of freedom is 58. So how do we, in statistical language, how do we explain this one? For a 95% confidence interval, the critical value with 58 degrees of freedom is approximately plus or minus 2.001. Okay, since the calculated t static values less than the critical value, we reject the null hypothesis. Okay, I just write it here. Oh, you want me to write it here? Fine. Or I will just type it here so that then it will be very clear. Instead of writing it, I'll just see here in statistical language for a 95% confidence level, the critical t value with 58 degrees of freedom is approximately plus or minus. Here I cannot use that symbol. Plus minus means plus or minus. Okay, 2.001. So here we need to compare the calculate t statistic value with the critical value, right? Critical t value. The critical t value is 2.009 on the right side. On the left side is a negative thing. And the t statistic value in this case minus 13 is obviously less than the negative 2.001. Hence, we reject the null hypothesis. Since we calculated t statistic is less than the critical value, we can reject the null hypothesis. That's all. I'm going to save it. This is how you can do the hypothesis. In this case, simply in your data set, whatever the sample A, sample B, you can put it here. And that's all. Okay. And then use the same thing. You don't have to make any changes for the rest of the script. That's all. Okay. And simply select, keep the cursor here and click on run. It'll get executed and it'll give you the output. But obviously you need to specify this one. Okay. If you don't specify the value for your two different samples, it will not give. This is pretty simple, isn't it? So it gives you everything here. You don't have to break your head here. Next one is the unequal variance.